Hey guys, bonus video here. We were doing SAT math review. I have two SAT math practice exams. One I was doing in my algebra class, the other I was doing in my physics class. This question in my algebra class, I want to give a little bit better explanation. And in physics, we ran out of time for these last three, so I want to do those. All right, let's start with this math question here. This is going to be number 26 from the packet. 26. Flip over to that. All right, we got this function f is defined by this expression here, where a and b are constants and x and y are variables. Okay, so this function of g and h are equivalent, where k and m are constants, so k and m show up here. But remember, g and h are actually the same as f of x, so just rewriting somehow. Which of the following equations displays the y-coordinate of the y-intercept as either a constant or a coefficient? All right, so I write down what I got here. 26 is we got f of x equals a times 2.2 to the x plus 2.2 to the power b. Right? Right. Okay. And we know that a and b are both positive and that a is larger than b. So they give us all that. I think it helps to have a picture in your mind. Right, so we got x, y, this is some kind of exponential function. Is it? Now we don't know what a and b are, but they're just some positive constants. Okay? And x can be variable. Okay? So sum to the power of x. I think this is roughly going to look like this, right? Depending on what you choose for a and b, you might get different kind of graphs, but it's going to be that basic shape. So if we're looking for this y-intercept here, the key defining feature that you could use to plug and solve this is that, well, that's where x is equal to 0. Right, so when they say y-intercept, and you want to find something about the y-intercept, think that's where x is equal to 0. Right, and they can go from there. Now they give you this g of x is a times 2.2 to the x plus k, and they give you h of x is a times 2.2 to the x, and then separate from that plus m. Okay, remember, g of x and h of x are f of x. They're just rewritten with this k and this m. But let's try this. Let's plug in 0 and see what happens. So what is g of 0? So that's a 2.2 to the 0 plus k. Now 2.2 to the 0, well, that's 1. So this is a 1 plus k. Okay. Now, since now that would be the y value of this y-intercept here. Okay, so the y-intercept is at 0 comma a 1 plus k, or a plus ak if you like. This is a plus ak. Okay. But the key here is that this y-intercept is not a single constant or coefficient. It's this whole little expression right here. Okay, so that would not be one of the valid answers they're looking for. How about h of 0? H of 0, what is that? Okay, so that's a 2.2 to the power of 0, and then separate from that plus m. Okay? Again, 2.2 to the 0 is 1. So this whole thing comes out to a plus m. Okay? Now, if you tell somebody the power of 0 was 0, or if that flashed in your mind, then say, oh, it looks like the y-intercept is just at m, and that would have been the answer. Or if this somehow zeroed out by some other means, okay, and you just got y is equal to m, then that would have been what they're looking for. But in this case, that's not what's going on, right? So this y-intercept is at a plus m as the y value. Okay. So the answer is D. Neither of these equations express the y-intercept as a constant or coefficient. So D, neither g of x nor h of x. All right, there you go. So there's a little bit better explanation of that one. All right, let's flip over to the packet I was doing in my physics classes. All right, so it's just these last three right here. Right. So number 25. All right, we got this linear system here. Write this down, 25. Okay. As soon as you see this linear system, it's like, oh, okay, this can't be that bad, right? But they asked that kind of a curveball question here. Okay, so we write the system down and get that. Okay. So here's your system. Actually, before I get to the question, let me point out something about the system that you may have noticed when you're writing this down. Okay? So you have 2x plus 3y 7, 10x plus 15y is 35. Okay? Now, normally if you have two straight lines, there might be like one place where they cross, and that's where you set them equal to each other. Okay? But the exception to that is if they are either parallel lines, there's no solution, or if they're the same line, they're right on top of each other, we call that infinitely many solutions. Look at these coefficients. Look, the ratios. 2 times 5 is 10, 3 times 5 is 15. Huh. Right? And 7 times 5 is 35. Oh, so this bottom equation is the top equation. It's the same thing. Right? If you scale every single term by a factor of 5, these are the same equation. Okay? So what at a glance look like a system of equations are actually not so much. It's just a single equation. So actually we can just strike one of these and just focus on the other. Right? We can actually this top one looks simpler. So let's totally ignore the second equation, just go with the top one for whatever question they ask here. For each real number r, okay, no, that's already kind of ambiguous. Right? We're going to plug r into what? Into x, into y. Okay, and what could it be? It's not a number, it's a letter. Right? Which of the following points lies on the graph of each equation in the xy plane for the given system? Right? Well, it says each equation. Again, they're the same equation. So I'm just going to feed this r into one or the other. Right? So how can we do this? Okay. All right, so my first thought is, hey, maybe we could plug in R for S. So let's try that. Plug in R for X. Okay. We'll play around with that and see if it leads to one of the multiple choice answers. Maybe it does, maybe it doesn't, but let's see what happens. So we got 2R plus 3Y is equal to 7. Okay. Now in this case, since okay, we're going to solve for Y, and then that would lead to r comma something, and then whatever this y comes out to be, okay? Which looks like it matches two of their choices here, right? R comma something, R comma something, right? Looks like possibly either C or D if this comes out to be an answer. So let's see if it does. So you got 3y equals negative 2r plus 7, y equals negative 2/3 r plus 7/3. So negative 2/3 r plus 7/3, kind of squeeze in there. Okay. But do I see that as a multiple choice answer? No, I mean, okay, C and D, not quite. So, okay, so it's not exactly either of those. So it's not that, it's not that. We hit a dead end. Uh-oh. But you know what? There's another approach I could take is what if I plug in R for my Y value instead? Okay, I could take that approach and see what is X. Okay, and see, okay, that might possibly lead to the answer B because it looks like this B has R is the Y value, right? That's kind of this approach here. And so maybe that'll lead to something. We're gonna see. And so I'm gonna do 2x plus 3r equals 7, okay? And then solve for x, and maybe that will be the answer B, possibly, or we're gonna find out. Right, so I got 2x equals negative 3r plus 7, x equals negative 3 over 2r plus 7 over 3. Right, so if this is the answer, it would look like some coordinate. Again, instead of x, it's this whole expression, negative 3 over 2r plus 7 over 3, and then comma. And what was y? Well, I plugged in r for y, so y is r. Okay. Okay. So maybe it's that right there. Again, if it's offered as a multiple choice option, right? So let's check out B right here, and that's did I sorry, this is 7 over 2. Oops, little typo there. Let me go back into that. It's the same way. Okay, there you go. I don't know why I did it divide by 3. That looks better. That looks better. Sorry, that's a 2, guys. That's a 2. Okay. And that does match the answer. Bing! So that's it. That's it. It's right there. So the answer is B. The answer is B. Okay, so there you go. Okay. This is one where yeah, you kind of somewhat at the mercy of what do they choose as multiple choice answers. You know, sometimes you have to just like plug them in and play with them. Right? This one takes more time than a lot of the other questions from the packet. Yeah, so that's a pattern to look for too for SAT is like the last few questions, they get a little tougher, it's gonna take more time to think about them. Okay, so I would say as a strategy, maybe do the first 20 questions a little faster and then the last 7 questions, it's gonna take a little bit more time. I expect that. All right, number 26. Ooh, yeah, this one. Okay, we got x squared over root x squared minus c squared equals c squared over root x squared minus c squared, and then whole thing plus 39. Okay. And it says, what's one of the solutions to the equation? If you look at their multiple choice answers, they're all in terms of c, right? So I think it's implied x equals something, like we're solving for x, okay? Now my first thought was, well, get a common denominator. So it takes 39 multiplied by root x squared minus c squared, right? And then rearrange it, and went through like a whole quadratic process and ended up being really complicated. So I think if just to skip that, because I did it before I started the recording here, let's try a different approach. And the different approach is, let's just go ahead and go down the multiple choice answers and plug these in and maybe eliminate the wrong ones, or find out something that actually does work using that method. So let's try it. Let's say option A says negative c. So I see the x, I'm going to put negative c and see what happens. So negative c being squared minus c squared. Okay. Already right there, I'm running into an issue. Right? Because guys, negative c being squared, well, that is c squared because the negative disappears. Minus c squared, well, that would be 0. Square root of 0. I would be dividing by 0. So divide by 0, which is something you're definitely not allowed to do in math. So that tells me that A is probably not the answer. And if I have limited time on this exam, I would just cut that right there and move on. Okay. Divide by 0. Okay. So let's try option B, see what happens. So, okay, negative c squared minus 39. So x equals negative c squared minus, 39 squared. Okay, I'll put a question mark because we're going to test this. Okay, so we got x squared over root. Okay, negative c squared minus 39 squared. Whole thing squared minus c squared. E. Okay, equals, okay, and then same thing over here. You know what? Since these have the same denominator, and this is a Wackerle expression, I'm just going to subtract this over and say minus c squared here and shove that all together. Okay, equals 39. Right. This is equal to 39. Oops, I forgot to replace this x with this expression. We do that. Negative c squared minus 39 squared, and then that whole thing squared. Okay. Right, so this might take a while to play out, but let's see. Okay, and I'll put a question mark here because we're going to test. Right, so I got negative c squared being squared is positive c to the 4. Right, and then e, yikes. Well, I'll just leave 39 squared is 39 squared. Okay, and negative, it's going to become a, actually, you know what? This whole thing's negative. Squaring is just positive anyway. 39 squared c squared, and then times 2, because I'm foiling right now, I'm doing FOIL. Okay. And then that'd be plus 39 squared, that's 39 to the 4. Right, then minus c squared, and this whole thing is over this. Okay, so that's like c to the, okay, well, is that same thing as that? C to the 4 plus 2, 39 squared c squared. All right, and then plus 39 to the 4, and that whole thing minus c squared. My intuition says this is running into a dead end. Okay. Let me try, because if c can be anything, right, to make this true, what if I just plug in 1 for c? Let me try this. I'm going to let c be 1, and I'll see what happens. So this would clean up as, okay, is this equal to 39 is the question. Okay, so is 1 plus, let's see, 2 times 39 squared plus 39 to the 4 minus 1. So okay. Divided by 1 plus 2 times 39 squared plus 39 to the 4 minus 1 down here. Is that equal to 39? Okay, I suspect not. Let's see. 2 times 39 squared plus 39 to the 4. Okay, and then all that divided by the square root of 2 times 39 squared plus 39, 4. Okay. Yeah, 15 22 is not equal to 39. Right? Okay, so the answer is not B. Right, so it's not A, it's not B. Right. So no, no. Let's move on to option C. Ooh, man, these are getting really wacky. Okay. You know what I'm gonna do? Now I'm thinking of it. Okay, I'm gonna let C be one, right? And that would greatly simplify this, right? So let's try this. Because if C could be kind of anything, right? Like universally, you could plug in whatever you want. It should work for any number. So let's plug in the simplest value you can. Right, so option C says x equals negative square root 39 squared minus, and I'm just going to plug in 1 for C. So something like that. Right, so then I've got now x squared up here. And if x is this negative square root, if I square that, that would be positive 39 squared minus 1. Right, so that's the place of x squared. Okay. And then I'm going to subtract over the c squared and this over this common denominator. And so that would be like this minus another one. And then over square root, and this whole thing is equal to 39 question. Okay. Okay. X squared, which again is this being squared is 39 squared minus 1. And then minus c squared. All right. C is 1, so c squared is 1. Okay. So is this equal to this? Wait a minute. This bit is equal to this bit, the square root of stuff. I don't think so. 39 squared minus 2 divided by the square root of 39 squared minus 2. Right? Yeah, so 38.97 is not equal to 39. Right? Now, since let's set C equal to 1, these are fairly close to each other, but they are not the same. And if you let C be something else, like any other number, but these would deviate even more. Right? So I don't think C is the answer either that we're looking for. Great. Right. So yeah, so we eliminated all those. Right? So process of elimination here, it's probably D. Let's try D. So option D says x is equal to negative root c squared plus 39 squared. Right, let's plug that in. Right, so again, we're doing x squared. So let's go ahead and square this, save myself a step. C squared plus 39 squared. Okay. And then I'm going to subtract over the c squared here because they got the same denominator. Okay, so minus c squared. Actually, that's just that. Okay. And then all divided by the square root of x squared minus c squared. So x squared. Okay, x squared would be like that. And then minus c squared. Okay. Is this all equal to 39? Right, so if this works, this would be the answer. Okay. Well, this cancels, this cancels. Okay. And then I have 39 squared over the square root of 39 squared is 39. Is this equal to 39? Okay. And yeah, 39 equals 39. Check. Okay. So that's got to be the answer. It's D. The answer is D. So it worked. Okay. Again, maybe you could have solved this from scratch. I tried it before. I was going down quadratic lines. It's get kind of crazy. Okay. I tried this method going one by one, and it looks like A, B, and C all were not working. Okay. And then I tried this D method, and okay, check out. So sometimes that's the fastest way to solve these SAT questions, is to play off the answers and just plug them in and see what works. All right, last question, 27. Ooh, this one's a fun one. We got, here, pull this up. See, it's better. Okay. We got a quadratic function. They tell you right off the bat it's quadratic. So think parabola. Quadratic means parabola. I'm going to write that down. We need a parabola. We're just going to take the form well, actually, let's read the question second. Model is better. They say they're calling it G. I'm going to change that to H for height or maybe D for depth or something. Or models the depth in meters below the surface of the water of a seal T minutes after the seal entered the water during a dive. The function estimates the seal reached its maximum depth of 302.4 meters at the 6-minute mark. And then it came back to the surface at the 12-minute mark. Based on the function, what's the depth of the seal at the 10-minute mark? Ooh, so I do want to draw that up. All right, let's go. Oh, okay. something like this, right? There's gonna be t minutes have passed, and well, they do call it. Okay, you know, actually, I'll just go ahead and leave this as G, or like call this depth. Okay, they were saying G or T. Okay, so how deep is it? Okay, now actually I've already done this. How do I do that? Well, here, because I wanted to draw like that. Okay, this could be the water level, so this could be depth 0. Okay, and the seal is going to dive down into the water and come back up. Okay? And they said the word quadratic, which means parabola. So it's going to depth as a function of time is going to follow parabola. We know at the 6-minute mark, it's reached its maximum depth, and at the 12-minute mark, it's back at the surface. Right? It kind of implies at the 0-minute mark, it's also starting at the surface. Right? So we have this type of parabola. Right? Now, parabola, I can do y equals a x squared plus bx plus c. Okay? But we can simplify this even better. Right? So I'm going to say g of t in the place of y equals a. Now instead of x, I'll call it t squared plus bt. Okay, but look at this. Look at this. At time 0, it's at depth 0. So the c just goes away. Okay? Just goes away. Okay? So we're just going to eliminate that. Okay? We have now a much simpler equation. Okay? Now, remember for this vertex about parabola, vertex is at negative b over 2a. Okay? So the conundrum here is we don't know what a and b are, but if we can get those, then we can answer any question, including at what time was it at the depth. Wait, what is it? No, sorry, the 10-minute mark. Right. At the 10-minute mark, what was the depth? Right. We're trying to figure out 10 minutes. What's going on here? 6, 8, 10. It's probably about there-ish. We're gonna find out. We do know it goes down to, it says 302.4 meters. I'm gonna change that to yeah, here. 302.4 meters, something like that. So I wonder if I should change that to negative to match my picture. Here, I'm gonna do something weird. I'm gonna flop these axes and just leave this as positive. Right, but you guys get the idea. Okay. So if this, okay, and that corresponds to that, corresponds to that. Okay. All right. So negative b over 2a so, has to be, well, this is at the x value, the t value equals. Okay. So 6 equals negative b over 2a. So cross multiply, I got 12a equals negative b, or negative 12a equals b. Okay. Some version of that. Okay. I'm going to hold on to that because now I have a relationship for a and b here. Okay. What else do I know? I know that the maximum depth is 302.4, so put 302.4 here. Okay. And that's going to be at the time 6 minutes. So it'd be like this, plus b times 6. Okay. All right. Now I can plug in this right here. These right there, right there. There we go. And that substitution is going to get it for us. It's going to let us, everything else is going to unfold. 302.4 equals 36a. Okay. Plus, now in place of b, I'm doing negative 12a, negative 12a. Okay. And then I got this times 6. Still got that. Okay. So this is like 72a. Okay. This is negative 72a. So 36a minus 72a, 302.4 equals negative 36a. Right, so then 302.4 over negative 36. Okay. A equals negative 8.4. All right, that's a key number to have. Great, we got that. Okay. Now combine that with this. And we'll get B. All I have to do to get B is just multiply by negative 12. We know that from before. Times negative 12 equals 100.8. Okay. Now we can put together the whole equation. We got A, we got B, we're ready to move on. Okay. And once we get the equation, we can plug in any particular value and solve for anything. So I'll have G of T, where remember G, T represents the depth, okay, equals, okay, got it right here, negative 8.4 t squared plus 100.8 t, and then plus 0, so I'll just leave that off. Okay. And the target question is, if you plug in 10 minutes for time, so where t goes, I'll put 10, okay, because all the times have been in minutes so far, so all the units are still consistent. Okay. So what is g of 10? So g of 10, and that will be the answer. So negative 8.4 times 10 squared plus 100.8 times 10. I'm looking at 168, and the unit is meter, but remember, SAT does not want you to include the units. Okay? This is not multiple choice. So you had to do this whole process and write down the number, and the number is 168. I'm looking at the answer key. The answer key says 168. So that's exactly it.